My data science friends, I'm making this video to remind us of the problem of the standard deviation and variation in statistics. We have to be very careful because we can run into the situation where we confuse the population standard deviation with the sample standard deviation. And notice they are very similar formulas with the exception that the population standard deviation is being divided by n, the total number of observations, but this is the entire population. And the sample standard deviation is being divided by n minus 1, the total number of observations in the sample. So it is the case also that you can see that the Greek letter is being used for the entire population, and the lowercase letter is being used for the sample population. Depending on what kind of data we're looking at, we have to be very, very cautious about the difference between these two things. If I have access to the entire population data, I need to be using standard deviation and variance formulas that deal with the entire population and dividing by n. Dealing with a subset of the entire population because I don't have access to the entire population. In other words, I'm taking a random sample of the entire population. Then I need to use the sample population standard deviation. Is an R. R does not have the standard deviation command for the entire population. Instead, its assumption is that the data you're giving it is a random sample, and so it's computationally taking the random sample standard deviation. All right, let's look at an example. This is the same data that we had before for the 2015 populations of all 50 states. Clear here, this is the actual entire population of all of the 50 states in the United States. This is not a sample. So when I'm dealing with the sample, I would take the sample standard deviation and variance. But here I have actual access to the entire population of reports of the population of all 50 states. So in this case, I have the population. So in Excel, there is a command for this, right? So there's standard deviation, and the standard deviation, see how it says the dot P? The standard deviation based on the entire population. Well, this is the one I would want in this example because I have the entire population of all 50 states. Turns this 7142605. So the sample standard deviation would be different. So that's standard deviation, and this is S dot S for sample. And so this dot S is the sample. So if I did the same thing in this one, we would get a different value. And the reason I'm getting a different value is because in the population case, once again, we're dividing by n, 50, and in the sample case, we're dividing by 49, n minus 1. That's why there's different results. Okay, but of course the trick is that if I reported the sample standard deviation for this particular data set, that's incorrect. It's incorrect because it's not a sample, it's the entire population. So this sample situation would be incorrect. And so that's the type of thing I have to be careful of as a practicing data scientist. Do I accidentally report information that's not correct? Right? And that's a significant difference between the sample population for the sample standard deviation and the population standard deviation. Something I have to be extremely careful. So let's take a look at R. So I'm going to copy this data of the 2015 state populations and look at R. So I'm going to do population of 15, and that's equal to scan. I'm going to use the scan command. It's read all 50 states. So if I use the standard deviation of the population of 15, then I get this number 7215121. That's the same as the sample from Excel. So the default in R is the sample. Because again, often in statistics, I don't have access to the entire population. So the default would be the sample. R doesn't have a built-in command for the population standard deviation. However, there is a package that does include a command for the population standard deviation. And that package is called sjstats. So that's this sjstats package. So I have loaded this package, and then if I type in standard deviation underscore POP, that's the entire population, and I put in my population of 2015, I get the 7142605, which again is 7142605 is the population. Once again, be very, very careful about the difference between the standard deviation and variance of a population versus the standard deviation and invariance of the random sample. Now, the author of our textbook points this out in 14.6.1. He doesn't go over this SD underscore pop command that you can get from the sjstats package. The author of the textbook just shows you how to do it using commands, but we can use this sjstats package if we need to. One thing the author does point out, which is important to know again here in this video, is the idea that oftentimes we can be a little sloppy about the difference between the population and the sample if, and only if, our sample size is getting bigger and bigger and bigger and bigger. Okay, so take this example. Let's say I had somewhere around 300 million people in the United States, and I took a sample of 50 of those people. Well, there's a huge difference between 300 million N and 50 minus 1. A huge difference. But if that population was 300 million and I took 1,000,000 samples, well, now N is a lot different than N minus 1. But you can see as it still is different, right? It would be 300 million versus 1 less than 1,000,000. But notice what happens as this N gets bigger of my sample. As my N of my sample gets closer and closer and closer to the N of my population, then this number is really big. This number is approaching that really big. The sample standard deviation is going to get closer and closer and closer and closer to the population standard deviation. So often it's the case in big, big data sets, big science data sets, where I have several 100,000 or several million sometimes data points. I'm not too concerned about the difference between the sample standard deviation and variance and the population standard deviation and variance, because as my sample gets bigger and bigger and bigger, I'm approaching the population. And the difference by dividing by something that's close isn't that much big of a difference. So that's just something to think about. But in the case, for example, of the 50 states, there's only 50, right? And so that is a much, much different case. It's not a very big data set. It's pretty small. It's only 50. So if I only have 50, then I have to be very careful to make sure I use the correct population standard deviation and variance versus a sample. Once again, though, if I had an actual population that was in the millions, let's say, and I only chose 50, well, then I make sure I use the sample standard deviation. Okay, I hope this video helps remind you of the difference between the standard deviation of the population and the standard deviation and variances of a sample.